Hi everyone. I want to go through the waves investigation. Um, I just recently finished grading it, and while some students had no problem with it, there was at least one perfect score. Quite a few students did not seem to really understand how to get the right answers. And so I'm not going to talk about the first three questions. Those are pretty straightforward, and you could just read the class web page on waves to get this information. But I want to work on the third question right here. Um, so the first thing I want to do is to show you where this information is. Here's the class schedule. And I hope, by the way, everybody is looking at this regularly because this has a lot of very important information. If you're not reading the materials listed under topic here, you really are not doing what you need to do well in this class. So let's scroll down to waves. And notice waves, this material will be on the third exam, which is coming up at the beginning of next month. So let's click on waves and scroll down here. And the first thing I want to show everybody is this right here. I'm sure you realize that there is what's known as the wave base, or the level of no motion. And to just remind you, the depth of the wave base is equal to 1/2 of the wavelength. If you have water depth that's deeper than the wave base, then this is known as a deep water wave. If you have water that's shallower than the wave base, shallower than 1/2 the wavelength, then this is known as a shallow water wave. Okay. If we scroll down some more, we can see what controls the speed of ocean waves. And while I give you this very complicated equation, I also tell you you don't need to know that equation. You will never in this class use that equation. What I do want you to notice is that the things that go into this are gravity, the acceleration due to gravity, the wavelength, L, and depth, right there. And the good thing about this equation is that it simplifies if you are in water deeper than the wave base or shallower than the wave base. If you're in water deeper than the wave base, so you're a deep water wave, this horrible equation up there simplifies to the square root of gravity times wavelength divided by 2 pi. And since gravity is the same everywhere on Earth, it's 9.8 meters per second squared, and 2 pi are just numbers, we can take the square root of those and move them outside of this, and we will have, if you take the square root of gravity divided by 2 pi, that's equal to about 1.25. It's actually this number here, but close enough to 1.25 times the square root of the wavelength. And what this tells us is, first of all, it's an easy way to calculate the speed of a deep water wave, but also it tells us that in deep water, the only thing that you have to know in order to get the speed of a wave is the wavelength. That's the speed of a deep water wave is entirely determined by the wavelength. In shallow water, where the depth is less than the wave base, depth less than L over 2, this same equation simplifies to the square root of gravity times depth. And again, since gravity is the same everywhere on Earth, it's a constant. If we get the square root of 9.8, that's about 3 point that, which is pretty close to 3.1. And so the speed of a shallow water wave is going to be equal to 3.1 times the square root of depth. And this tells us that in shallow water, the only thing that determines the speed of a wave is the depth of the water. It's the speed of a wave in shallow water is entirely determined by depth. Now, one other thing to remember, first of all, remember that for all waves, the speed is defined as being equal to the wavelength divided by the period. And that's true whether we're talking about an ocean wave, a sound wave, a light wave, a gravity wave, any kind of wave at all. The speed is always determined by the wavelength divided by the period. Now, if we take this equation, multiply both sides by the period, that will isolate L, the wavelength on one side, equals the speed times period. And since in the equation for a deep water wave, we have L here, if we put in CT for that, if we move things around a little bit, and you can do this on your own, we will also get speed equals again, for a deep water wave only, the speed equals gravity divided by 2 pi times the period, no square root. Now, why is this important? The reason that this is important is that if you are, say, out on the ocean in a ship or a boat, it's really difficult to measure the wavelength of a wave, practically speaking. But all you need to do to measure the period of a wave is to get a stopwatch, and that can be a stopwatch on a wristwatch, that can be an old-fashioned stopwatch, that can be a stopwatch on your cell phone. Wait till the crest of one wave is under your boat, so it's lifted you up. Start the stopwatch. Wait till you're dropped down into the trough of a wave and lift it up by the next wave, and then stop your stopwatch, and that will give you the period of the wave. And then all you need to do is take gravity divided by 2 pi, and when we do that, we get 1.56. 1.56 times the period of the wave gives you the speed. Remember, this is only for a deep water wave. Okay, now that we know that, we can go and look at question 4 for the waves investigation. Now, one thing about this is that there's a bunch of rules here, and this looks like a lot. It looks very picky. The problem is Canvas is extremely picky in how it recognizes answers. What I need to do for this question is I need to make up a key so that Canvas can recognize your correct answers. And if you don't follow these rules, Canvas will not recognize your answers. It's not a hard thing, but it is something that's necessary to do so that I don't need to spend an enormous amount of time hand grading your answers. So let me go through some of these really quickly. First of all, you don't need to write C equals. I know you're calculating your speed, so just leave that out when you're writing down an answer or writing down an equation. When you're writing down a numerical answer, a lot of times when you make a calculation, you'll have a huge string of digits after the decimal. They're not important. I want you to use no more than one digit after the decimal. When you're giving a numeric answer, you should always use units. Okay, you have to use the units. So if you make a calculation and the speed is 50 meters per second and you just write 50, that's not correct. You have to write 50 meters per second. And the one place where there is an option, you can put the space there or not. I've got both of those in the key. When you're writing out meters per second, use m/s, not these. Okay. Don't write out a long string of equations like this. It just makes things more difficult. Another rule, don't put spaces into the equation unless absolutely necessary. So, and there's no place where they're really necessary. So if you're going to be multiplying 5 times 3 and adding 2, just write 5 times 3 plus 2 or x times y plus z. Don't leave spaces in between them. Why am I doing that? Well, imagine that I allowed you to write it either way. That would mean that with all the different ways of writing this, I would have to have twice as many answers if you put spaces in. So don't put spaces in there. We don't have a square root symbol in Canvas. So when you're taking a square root of something, write it out this way. Square root and then parentheses, symbols, and put whatever you're getting the square root of between the parentheses symbols. Don't write SR of, just write it this way. Okay. When you're multiplying something, sometimes people use an asterisk, sometimes people use an X, sometimes people use parentheses, sometimes people just put them right next to one another. All of these things ordinarily are fine, but that's 4 different ways of multiplying. That would make it may have to have 4 times as many answers in the key as I would ordinarily. So the only way that's valid is to put an asterisk there. Please do that. You'll see similar things on the exam as well. If you don't do these things, then you won't get full credit. Okay, these were right at the beginning of this problem, and when students didn't follow these directions, then I gave half credit. I didn't give full credit for this. Okay, so there's 5 different waves. You're going to have to calculate the speed of these 5 different waves. So let's take a look at them. First of all, we have a wave with a wavelength of 100 meters, water depth of 4,000 meters. Notice that very often wave height is in here. Wave height is just there so that you can show that you know that wave height is not one of the things that determines the speed of a wave. Ignore it. So, is this a shallow water or deep water wave? Remember that when the water is deeper than 1/2 the wavelength, it's a deep water wave. If the water is shallower than 1/2 the wavelength, it's a shallow water wave. The wavelength is 100 meters. Half of that is 50 meters. Clearly, the water depth is deeper than 50 meters, so this is a deep water wave. Now, you can just write deep. You can write deep water. You can write deep water wave. Any of those will be okay. And by the way, the one thing that Canvas does do is it ignores capitalization. So you could write this, you can make every other letter be uppercase. It doesn't matter. Okay, what's the speed of a wave in meters per second? Well, to do that, you have to use the deep water wave equation. The deep water wave equation is either square root of gravity times wavelength divided by 2 pi, or more simply, 1.25 times the square root of wavelength. We can write out square root of gravity times wavelength divided by 2 pi, and use pi like that as your symbol for pi. Don't put the number in. And when we do that, we can take 9.8, what's the wavelength, times 100 divided by 2 divided by, and pi is 3.14159, and there's a whole bunch of other digits that I don't remember. And that gives us this number, and then when we take the square root of that, we get 12.48888. And since I asked you to just put one digit, this rounds to 12.5. So our answer here would be 12.5 meters per second. Oop, sorry, that's in the wrong place. 12.5 meters per second. Our second wave has a wavelength of 64 meters, water depth of 16.5 meters, and again, this is irrelevant. So is this a shallow water or deep water wave? The wave base is 1/2 the wavelength, so 1/2 of 64 is 32 meters. And so the water depth is 16, so 16 is less, or it's shallower than 1/2 the wavelength of 32. 16 is less than 32, so this must be a shallow water wave. So what's the speed of a shallow water wave? Well, if we go to our shallow water wave equation, we can either use the square root of gravity times depth, or we're going to be simpler here, 3.1 times the square root of depth. 3.1 times the square root of depth. Oh, and by the way, I should have had, no, I didn't. That's okay. Okay, and so depth here is 16 meters. Do we really even need a calculator for this? 16, the square root of that is 4. 4 times 3.1. I'll show you the calculation here. 4 times 3.1 equals 12.4, which happens to be very close to the previous answer, 12.4 meters per second. But really, 4 times 3.1, 4 times 3 is 12, 4 times 0.1 is 0.4. You don't even need a calculator for this. Okay, let's look at our third wave. The third wave has a wavelength of 100 kilometers. That's a huge wavelength. 100 kilometers is about 62 miles long. What kind of a wave has a wavelength 62 miles long? The answer is a tsunami. Tsunamis form when there are underwater earthquakes that either raise or lower a large part of the ocean floor. And because of that, the amount of surface area is enormous, because in earthquakes, a large part of the Earth's crust will be either raised or dropped. And that generates a wave with a very long wavelength, 100,000 meters or 100 kilometers. Well, the water depth here is 3,600 meters. 3,600 meters, that's 3.6 kilometers. That's it's about 2¼ miles deep. And you might say, well, that's really deep water. But remember that the thing that determines whether a wave is a deep water or shallow water wave is not the water depth alone, it's the comparison between the water depth and the wave base, which is dependent on the wavelength. So remember, the wave base is 1/2 the wavelength. 1/2 the wavelength, 1/2 of 100 kilometers is 50 kilometers. And remember that the deepest part of the ocean anywhere in the world is 11 kilometers in the Marianas Trench. So a tsunami has a wave base deeper than the ocean floor everywhere on Earth. Everywhere on Earth, it's a shallow water wave, because the water depth is always going to be less than 1/2 the wavelength. So this is a shallow water wave. So how fast does this move? Well, we're going to use the shallow water wave equation. And here's the shallow water wave equation. I'm actually going to cheat, cut and paste it. And when we put this into water depth, let's go to our calculator again. 3,600, the square root of that, of course, is 60, times 3.1 gives us a wave speed of 186 meters per second. Now, what is 186 meters per second? And you could put this in as 186 or 186.1 or 0.0 meters per second. Well, 186 meters per second, if you convert that to miles per hour, comes out to be about 380 miles per hour, which is a slow jet or a fast propeller-driven airplane. That's a very fast speed. And this is why tsunami waves are so dangerous. Tsunamis, oops, I put that in the wrong place. Excuse me. Don't make that mistake. There we go. Tsunamis travel very fast and they're very long, which means they contain a huge amount of energy And when these waves encounter shallow water, they get compressed, and this energy all comes ashore all at once, with the net result is that we get these huge towering waves. So this is a tsunami. Tsunamis travel, look how much faster that is than the typical shallow water wave here or a typical deep water wave. Okay, number 4 is a wave with a wavelength of 100 meters and a wave period of 20 seconds. Notice we're not given the depth of the water. And because of that, we don't know whether this is a shallow water or deep water wave, but it does not matter because we are given the wavelength and we are given the period, and we know that the speed of a wave is equal to wavelength divided by period, no matter what kind of wave it is. And so 100 minus 20, do we even really need a calculator for that? That's going to be 5 meters per second. Our last wave, right here, has a wave period of 10 seconds, a water depth of 4,000 meters, a wave height of 10 meters. What's missing here? What's missing is the wavelength. So we don't know what the wavelength is, but we are told that we should assume that this is a deep water wave. The speed of a deep water wave, if you recall, is equal to 1.25 times the square root of the wavelength, or the square root of gravity times the wavelength divided by 2 pi. But remember, we discovered that we could also use this equation to get the speed of a deep water wave, and all that we need to know in that case is the period. So if we go back to our question here, we've got a period of 10 seconds. We know that the speed of a deep water wave, 1.56 times the period, and so 1.56 times 10 is 15.6. All you got to do is move the decimal, meters per second, and that gives us our final value. Even though we didn't do the first 3 questions, I'm going to submit this. We didn't do these. And notice that this question is worth 65 points. Now let's submit it. And notice that we get 65 points. So that doesn't use the first 3 questions here, but the rest of it, we got it all correct. So this is how you do this. If you have any questions on how to get the right answers for this, please come and talk to me. Another thing that I really strongly suggest is looking at the old exams, and you can do that by going back. Actually, I think I just have this. Go look at the old exams, which you can access through the main class web page, not the Canvas page, but the web page. And you'll notice that in every single case, there's a question about calculating the wave speed. Make sure you know how to do that for any of those questions, and you should be able to do it for the exam, which again is going to come up in the beginning of April. If you want, go answer those questions, and if you want me to check them, then contact me through Zoom, and I'll let you know whether you're on the right track or not. Okay, good luck, everybody.